Hello friends, welcome to my channel Physics Moji. In this class, we are going to discuss some important essay questions for the final exams. So let us start our discussion with the first activity, that is finding specific heat of lead shots. For solid, that is lead shots. Coming to the activity, the aim of the activity is to find the specific heat of lead shots. For this, we need a calorimeter, lead shots of at least 50 gram, thermometer, steam heater, stirrer, and water. So these are the apparatus that are required for conducting the activity. Now coming to the procedure, first point is take a calorimeter and measure its mass. Take a calorimeter and measure its mass and note it down as m1. So mass of calorimeter is m1. So this is the calorimeter. Initially the first step is to find the mass of the calorimeter and note it as m1. So if you observe here, some of the readings are in blue color, so they are important for us in the derivation of the formula. Okay, so the mass of calorimeter is m1. Now fill this calorimeter to 1/3 of its volume with water and measure its mass. So now fill this calorimeter to 1/3 of its volume with water and then again measure the mass. So in the first step, the only mass of calorimeter is m1. Now along with water and this calorimeter, now the total mass is m2. So m2 is the total mass of calorimeter along with water. So the mass of calorimeter plus water, noted as m2. So if I want only the mass of water, then I will take the mass of the water is equal to m2, the total mass of calorimeter plus water, minus the mass of calorimeter. So mass of water can be noted as m2 minus m1. Next, measure the temperature of calorimeter and water and note it as T1. As the water and calorimeter are in contact with each other, they attain same temperature. So find the initial temperature of this water and calorimeter and note it as T1. So the initial temperature of calorimeter and water is T1 degree Celsius. Now take some lead shots and place them in hot water or a steam heater and heat them to a temperature T2, say 100 degree Celsius. So in a small bowl or in a steam heater, take some lead shots and heat them to a temperature of T2. So let this temperature be 100 degree Celsius. Okay. So after reaching this temperature, the next point is transfer the lead shots immediately into the calorimeter and stir it well. So immediately transfer the lead shots into the calorimeter and stir them well with the stirrer and measure the final temperature of this mixture. So what is the mixture? With the mixture of calorimeter, water and lead shots. So they attain a final temperature. Let the final temperature of this final the mixture be T3 degree Celsius. And again measure the mass of the calorimeter with water and lead shots and note it as M3. So mass of calorimeter plus mass of water plus lead shots, all of them has a mass of M3. Out of this, if I want only the mass of lead shots, I will subtract M2, which is the mass of calorimeter plus water. So the mass of lead shots can be noted as M3 minus M2. And final temperature of the mixture of calorimeter, water and lead shots, that we already noted as T3 degree Celsius. So I already said you that this blue colored readings are important for us for the derivation of the formula for finding the specific heat of lead shots. Now let's move on to the derivation part. So we know, according to the principle of method of mixtures, the net heat lost by hot body is equal to the net heat gained by cold body. So if you observe here, the calorimeter and water are getting heat energy from the lead shots. So we can say that the lead shots is losing the heat energy, whereas the calorimeter and water are gaining the heat energy. So according to the principle of Mathematical mixtures, the net heat lost by hot body. So here the hot body is lead shots. So the net heat lost by lead shots is equal to the net heat gained by cold body. So here the cold body is calorimeter and water. And we know the formula for heat gain or heat loss is Q is equal to ms delta T. So this is the formula for heat gain or heat loss. So here the lead shots are losing the heat energy, whereas the calorimeter and water are gaining the heat energy. So we'll transform this formula, this equation, by using this formula. So Q is equal to ms delta T. So here mass of lead shots, specific heat capacity of lead shots, and change in temperature of lead shots. So I am writing in terms of ms delta T. Q is equal to ms delta T is equal to mass of calorimeter, specific heat capacity of calorimeter, and change in temperature of calorimeter, plus mass of water, specific heat capacity of water, and change in temperature of water. So now we'll write mass of lead shots. So what are the mass of lead shots? So you can say mass of lead shots is m3 minus m2. Mass of lead shots is equal to m3 minus m2 into specific heat of lead shots and change in temperature of lead shots. So what is the change in temperature of lead shots? So initially the temperature of lead shots is T2 and the final temperature is T3. So as lead shots has given out heat energy, the T2 will be greater than T3. So the change in temperature will be T2 minus T3 is equal to the mass of calorimeter. So what is the mass of calorimeter? So the mass of calorimeter is m1. You can see the mass of calorimeter is m1. So mass of calorimeter is m1 and the specific heat of calorimeter SC and change in temperature of calorimeter. So initially the temperature is T1 and the final temperature is T3. As it gained heat energy, T3 will be greater than T1. So you can write the change in temperature as T3 minus T1 plus mass of water. So what is the mass of water? The mass of water is m2 minus m1. You can see here the mass of water is m2 minus m1. So mass of water is equal to m2 minus m1 into specific capacity of water into, as they are having same temperature, the change in temperature is also same. So T3 minus T1 for both the calorimeter and water. So here I want the value of specific heat of lead shots only. So send these two factors to that side. So the specific heat of lead shots will be equal to, so here T3 minus T1 common in both these. So take T3 minus T1 common, so that I can write M1 SC plus M2 minus M1 into SW. So coming to these two, here they are multiplying, so if they come to this side they will divide. So it is M3 minus M2 into T2 minus T3. So this is the formula obtained to find the specific heat of lead shots. Ramu says that the average kinetic energy of the molecules is directly proportional to absolute temperature. How can you support this statement? How can you prove that average kinetic energy of the molecules is directly proportional to absolute temperature? So this is activity 3. So the answer is I support Ramu's statement. We can prove this statement by the following activity. Coming to the procedure, take two bowls, one with hot water and the second with cold water. So take two bowls, one with hot water and the second with cold water. So we know the hot water will have high temperature and the cold water will have low temperature. Now gently sprinkle food color on the surface of the water in both the bowls. So take some food color and sprinkle in both the glasses. We will observe that the motion of the small grains of food color. We observe that the jiggling of grains of food color in hot water is more than the cold water. So we can observe that the particles of the food color moves faster in high temperature, that is hot water, when compared to the cold water. So the speed of grains is different in different waters. So we can conclude that average kinetic energy of the molecules. That means we know the kinetic energy is the energy that is possessed when the body is in motion. So here the motion of the particles is faster in high temperature, that is hot water, than the cold water. So we can say when we have more temperature, we have more kinetic energy. When you have less temperature, you have less kinetic energy. So the average kinetic energy of the molecules, the average kinetic energy of the molecules is directly proportional to absolute temperature. Next, moving on to the next activity. Activity 4. Which quantity determines the direction of heat flow? Do an experiment to support this statement, or show that heat energy flows from hotter body to colder body. So here we are going to prove that temperature is the quantity which determines the direction of heat flow. So for this we need water. This is hot water and this is coconut oil. So take water in a container and heat it to 60 degrees Celsius. So first take some water and heat it up to 60 degrees Celsius. Then take a cylindrical transparent glass jar and fill half of it with the hot water, and take a cylindrical glass vessel and fill half of its content with hot water. Next, very gently pour coconut oil over the surface of the water. Now take some oil which is at room temperature. So this hot water is at 60 degrees Celsius and this coconut at room temperature. So at room temperature, slowly pour on the surface of the water. Put a lid with two holes on the top of the glass jar. So close the glass jar with a lid having two holes for placing the thermometers. Take the thermometers and insert them through the holes of the lid in such a way that the bulb of one thermometer lies only inside the water and the other lies only inside the oil, as shown in the figure. So here you can see the bulb of one thermometer is only in water and the bulb of the other thermometer is only in water. So one is in oil and the other is in water. Observe the readings of two thermometers. The readings in the thermometer which is kept in water decreases and the reading of thermometer which is kept in oil increases. So we know here the water is at high temperature and oil is at room temperature. So that means low temperature. So the heat will flow from water to oil. So water loses heat energy, so the temperature will decrease and the temperature of oil increases. So the reading of thermometer of which is placed in water decreases and which is placed in oil increases. Here water loses heat energy and oil gains heat energy. Thus heat flows from water to oil. From this we can conclude that heat energy flows from hotter body to colder body, and also temperature determines the direction of heat flow. So this is the activity.